So in the previous video, we talked a little bit about parabolas and how I could write them in either of these two forms here. And this would be an x squared parabola that would open either up or down. And this is a y squared parabola, so it would open either to the right or to the left. And we talked about how the p-value here told us how to find the relationship between the focus and the vertex and the directrix were. So I'll sketch a little picture of an x squared one. So sorry, the graph's a little crooked. So we've got a vertex, we've got a focus. The parabola always wraps around the focus. This would be an x squared one with a positive p. I could flip it around, make it like this, or like this, or like this by changing between different options. And the p-value comes in that it becomes this distance here and this distance here. So, and we can use that to find different points, and I'm not going to talk about that because we just talked about it in the previous video. What we're going to talk about now is how we go about moving a parabola side to side or up and down. And to do that, we're going to go back and talk about how we would deal with an absolute value equation. So let me give myself some more space. If I asked you to graph y equals absolute value of x, then I would expect you to be able to, show me with your arms maybe or something like that. But it would be a pointy graph like this with this pointy part at the origin. We talked before about ways to move one of those around. So I could go and write, change colors. I could write y equals absolute value of x minus 5. And, that would change the nature of the graph a little bit. The way I like to think about it is that 0, x equals 0, is what makes me take the absolute value of 0 and gives me 0 out. So it gives me my 0, 0 point. So the question here is, what x value makes me take the absolute value of 0? Well, that's 5, because then I plug in a 5 here, I get 5 minus 5, which is 0. So that tells me that the vertex of this graph is out here at 5, and I can draw, or the vertex, the pointy part, whatever we want to call it, it's out there at 5. So what this does is it takes this graph and moves it to the right 5, because 5 is the number that makes me take the absolute value of 0, just like 0 makes me take the absolute value of 0 here. So the next one that I'm going to talk about is adding an up-down shift. So if I have y equals absolute value of x minus 5 plus 2, then what I can do, I'll do it down here, is it goes, 5 is still the number that makes me take the absolute value of 0. So that means that it's going to go over to x equals 5, because that's where the pointy part's going to be. But then I have this plus 2 on the outside. So what that does is it moves it up 2. So what I'm going to do is go and put a dot somewhere in the region of over 5 up 2. And I'm going to draw my absolute value so that the pointy part is there. And then I label it by writing 5, 2. And you should be able to do all that. That kind of goes back a ways in what we've talked about in Algebra 2, but it's still, it should ring bells for you. So now what I want to talk about, we're going to take and use these ideas with the parabolas that we just talked about. What I want you to notice with the green one that I circled is that it's in a y equals form. As opposed to this up here, this is x squared equals, and then there's a y embedded over here, and here I got y squared equals, and an x over here. So I'm not going to be able to move them exactly the same way as I did before. So I'm going to manipulate this green equation right here and write y minus 2 equals absolute value of x minus 5. Now what I've done is I've paired the minus 2 with the y and the minus 5 with the x. So I can go and I can identify that 5, 2 is 5 is what makes the x 0 and 2 is what makes this side 0, right? So that's how I get to my 5, 2. if I were to have something that looked like y minus k equals absolute value of x minus h, and you may say, well, where did those letters come from, k and h, and it's just the standard way to do it with these types of shapes, then this point would no longer be at 5, 2. It would have my starting point, or my pointy point, I'll call it the starting point, at, h comma k. So I'm going to take those ideas that we have right there and use them with parabolas. So let's go ahead and take that idea and apply it to some of the parabola stuff that we've just been working with. So I've got this new equation here, x minus 4 squared equals minus 12 times y plus 7. So notice I had a minus h on my x's, so here my h value is going to be that 4. And then I had a minus 2, and I looked at that as a minus k. And with the y here, I now have a plus 7. So the question is, what would I need that to be minus? So I could have minus a negative 7. So I'm going to go and now take this idea and apply it to figure out where this parabola is going to start. So I want you to try and guess where you think that this parabola is going to start, and then what direction it's going to open based on how this equation looks. So why don't you sketch that on your paper and pause. Okay, so as we said, h is 4 and k is negative 7. So what that tells me is that it has a vertex at 4 comma negative 7. Also, what kind of squared does it have? Well, it's got an x squared, so that means it opens either up or down. To figure out up or down, I need to look at this value. Well, 12, I'll do some scratch work over here. Negative 12 is equal to my 4a. So if I divide by 4, I get a equals negative 3. Since that's negative, so I'll write a equals negative 3. What that tells me, and since it's an x squared, I know that it's a parabola that opens down, because the x squared tells me up or down. The negative tells me that it's the downside of that. So I'm going to slide over a little bit more. Oops, I'm out of space. Let me pause. So now I'm going to go ahead and graph this stuff that I have the information written down for. So I know that the vertex is at 4, 7 based on this in my HK. So I'm going to go and tick 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. Put a dot and write 4 comma negative 7. Next, the a value is negative 3. Actually, before I do the a value, what I'm going to do is make it open the right direction. So I know it's got to open down. I'm not super concerned with how wide I make it. I just want to make sure that I open it down and then label the pieces in the right spot. So let's draw it in like this. Now the next question is, how does the a equal negative 3 help me identify where the focus and the vertex are? So since a is negative 3, that means that I go down 3 more and put a dot at that same x value. So that would be 4 comma down 3 more puts me at negative 10. And that's my focus, so I'll label it as F. And I should probably label this as V for vertex. And then the last thing I need to do is identify where the directrix is. So I had this at negative 7, so I go back up 1, 2, 3. 3 above negative 7 is negative 4. So I'm going to put a dotted line. The reason I make it dotted is because it's not part of the graph here, and that graph is solid. So if I make this a solid line, then I can't really tell if it's supposed to be part of this graph or not. So I'm going to call this D and then write colon. It's y equals negative 4. And that part over there is kind of the final product of my graph. The one thing that I have not included here is the lattice rectum, which we talked about in the previous videos. Think about it. This length is how long? 3 and 3. So that means that this length is 6. So if I go straight over, this is 6. Straight over, this is 6. So I should be able to label those guys. So I did go ahead and label them in red there. I want to point out that one of the reasons why it can sometimes be hard to label this part is because if I draw the graph first, you can see that this says it's a negative 210, and clearly on the right side of that y-axis, so it should be over to the left side. So you have to be really precise if you're labeling those spots. But for now, that's totally good. And you should feel good with doing this type of parabola that's been moved by one of these guys. And if I were to switch it to an x squared or to a y squared or something like that, change this a value, you should still be able to kind of build it using all the stuff we've talked about so far.